Hello, this is Mr. Ferreira, and I'm going to continue on the inferential statistics route and look at the Mann-Whitney or the U test. Now, you've been following a flow diagram that has several choices. The first one was about nominal data, and I will explain that inferential test last. But we looked at specifically the correlations, and that was down to keywords like relationship or correlation that would indicate that it is a correlation. We then start moving further down and we look at the experimental design. And we would choose the Mann-Whitney test if I knew that I was looking for a difference and we knew that we had a design that was independent groups. So because it's independent groups, we'd say that actually ultimately we're looking for a difference between groups. We have a study where we can clearly identify the two different groups and we can see that there's going to be a difference in scores between those groups. Effectively, we're doing a comparison between those groups. The third aspect, and I've put it down here as number 2, that we would consider, and our reason for using the Mann-Whitney would be that the data is at a level of measurement of being at least ordinal. And all this is basically saying is that it's not nominal data, it's not ratio data or interval data. We suspect that it's at least ordinal. Okay, so therefore what we would argue at this particular point is that we're looking at data that wasn't collected using some kind of stopwatch or measurement scale or ruler or something like that. So let's get into this, potentially looking at a hypothesis. But before we start talking about the hypothesis, what I do just need to remind you that the correct word or correct way to refer to hypothesis is actually an alternate hypothesis. I spoke to you previously about the null hypothesis being H0. So therefore, we can then expect that each time, now this is linking back to the features of science, each time we test your hypothesis or have a testable hypothesis, we can have H1, H2, H3, and we can continue until we have Hn, okay? So ultimately, each time we come up with a hypothesis, we're looking for an alternate explanation. So therefore, that's why we call it alternative hypothesis. So let's have a look at an example of an actual study that looks at kind of independent groups, data at least ordinal, and we're looking at a difference between groups or independent groups in terms of our study. And it's very simple here. It's a directional hypothesis saying that male participants who are interviewed on a high bridge give a higher rating of attractiveness to female interviewers than those interviewed on a low bridge. Now, it's clearly something which I wouldn't approve of, giving any form of rating of attractiveness for anyone, but the principle behind this is that they are interviewed by a female, and after the interview, they can get asked, well, what is the level of attractiveness? Now, the DV being either the high bridge or the low bridge. So it's quite clearly independent groups. We have a high bridge and we have a low bridge. You can't be on both. And I suppose we couldn't you couldn't do repeated measures because you would have some element of cognitive dissonance. You're kind of, if you thought somebody was attractive and then suddenly you meet them again and you think they're kind of less attractive or more attractive, there might be some issues there. Okay, so it's therefore independent groups. And we see that ultimately we are testing for a difference between these groups, and we could have data that looks a bit like this. Okay, another kind of clear clue that this could be independent groups is we see that there's 10 in the first group and 14 in the second group. This is very practical. It might be quite difficult to interview somebody on a high bridge, the practicalities of that. So therefore, it could just be that I can't get as many participants to take part in this. And you notice, just like correlation, they tell us the observed value. Now remember, the observed value can also be called the calculated value, okay? Because you're calculating it from your values that you collected on the bridge. So if you're running this particular study, you would interview these particular people, get their level of attractiveness, write it down, put it in a table, and then enter this data into a computer and come up with an observed value of 16.5. Okay, so we then have to guess or see the correct critical value, and the critical value comes from a critical value table. Now we see that this is for 5% one-tailed test. So another thing that is a little bit obvious for this is that if they had to be accurate in the exam, they're either going to just give you one table like this, or they're going to have to give you both tables, especially if it's not something which they say straight away about one or two-tailed. You have to kind of decide what it is. So we find in this particular case that it is one-tailed, so we have to look at this particular table, and we see that the first group had 10 in it, and the second group had 14, and the corresponding number is 41. Okay, so the critical value equals 41. Now don't be alarmed, 16.5 and 41 is not exactly a massive difference, but it is an indication as to what is going on. Now, something which is really nice about this particular test is it doesn't matter which is group 1 and which is group 2. So for example, if the low bridge was seen as being group 1, so that would be 14, and then we'd have 10, we see that it comes up with 41 as well. So it's very difficult actually to make a mistake in this particular context. And we see that the next thing we have to look at, it says for any n1 and n2, or in other words, for any groups that we have, the observed value must be equal to or less than the critical value. So what we then can just write that particular statement down. So the observed value was 16.5. Is it less than or equal than the critical value of 41? Well, 16.5 is actually less than the critical value. So we have a yes there. So in other words, it has met the criteria for the test. So therefore we say it's significant. Okay, so of course, if it's significant, we have to reject something. So we reject the null hypothesis. And so we can conclude quite literally that if you are interviewed on a high bridge, you will give a higher rating of attractiveness on of a female interviewer compared with being interviewed on a low bridge. Now, of course, if you're in the lesson, you would have we would have joked a lot about this. It might come up a bit in our relationships topic, but the truth of it is it's down to fear. And with fear, we find that people kind of almost rely on their instinct, and the instinct at this particular stage, or your is survival of the fittest. So as such, we still have to find the person that we want to mate with attractive. And in this particular case, it just means that we kind of, without being aware of it, ultimately we lower our standards because of fear, and therefore we find them more attractive. You could also combine this with a social factor if you wanted to, if people were kind of saying how wonderful you are or how wonderful they are. You might well actually be able to kind of be very successful in mating. So therefore, that's why it's probably a good idea for you to, if you do go to the cinema, maybe watch a scary film on a date. That should work. Now, you can pause the video at this particular stage, take an opportunity to see whether you can come up with the correct values for the critical value and compare it with the observed value and see how it goes. Okay. Now, I would always recommend you go to the statement and you do exactly what they say. It says here, the observed value must be equal than the critical value. So we've got to write the observed value down, 34. The critical value in this particular case, it's still directional, is 10 and 12. So let's get back to here, 10 and 12. We see that it's 34. So we write it down, 34. It says it must be equal to or less than, so therefore this is significant. So I would say that's significant, okay? The next one's a two-tailed test, 8 and 6. We see two-tailed 8 and 6. We see is there. This is 8, so therefore this is not significant. Okay, we have 7 and 14. One-tailed, was it? Let's have a quick look. 7 and 14. 7 and 14 is 26. So therefore, it's not significant. Therefore, the next one is 15 and 10. 15 and 10 is 39. So therefore, it is significant. And just obviously look at those types of values, even though they're quite significantly different. Don't worry about it. Just do exactly what they said. They said that the 12 must be less than 39. So therefore, it's significant. So I would hope that you are beginning to kind of see kind of how formulaic it is. It's all about spotting things like what type of table of data you might have. It's obviously about spotting things like what does the critical value table look like, and you'll see that actually the U test is actually, or Mann-Whitney test, is often asked in exams, and we see a whole host of the legacy papers asked about the Mann-Whitney, not necessarily always asking you to work out whether it's significant or not, but certainly asking you to kind of consider what it is, aspects about it. Okay, so that is the straightforward independent groups design. Okay, so the I would say the more complicated one is called unrelated t-test. Unrelated in that, of course, if they're independent groups, if you're independent of something, you can't be related to them. Okay, so that's why it's just called unrelated t-test. So we do the same. We have exactly the same reason one, difference between groups, exactly the same reason three. Okay, independent groups. But we see now we have these two options over here. So first of all, the level of measurement is at least interval. Okay, so in other words, what I'm doing is some kind of measurement scale. So I'm looking at a ruler, a set of weights. I'm looking at a stopwatch or something like that. Okay, but also we then add this normal distribution of the sample. And this is related to whether it's a parametric or non-parametric test as well. And we find that ultimately we use the unrelated t-test when we have kind of a normalized set of data. And this will be a typical example of that. Okay, so it says there's a difference in time taken by males and females to complete a jigsaw puzzle. Okay, now of course, it's quite general in terms of population, males and females, but that also indicates it's independent groups. But a key component here, of course, is time. Okay, so therefore, if it is using a stopwatch, it has to be interval data. Now, of course, is there significant difference between males and females in terms of taking time to draw to complete a puzzle? Now, they do actually say that this is a non-directional one, because what I'm not saying is men are better than women or women are better than men. We're trying to find out whether there is actually a difference between them. You might want to pause and just think, well, is there? And I suppose I become a bit repetitive here. We're doing exactly the same thing as we did for the Mann-Whitney. I'm not doing anything different. They have to give me a calculated value, okay? And I have to work out the critical value. Now, the only real difference is the critical value table uses something called degrees of freedom. And that's what the DF stands for. Okay, now I've thought long and hard about kind of how much is, or how important is this going to be for us? And part of me just doesn't really feel that it's that important, that it's either going to be like for some of the math students, it's going to be fairly straightforward and therefore not an issue at all. Or there's going to be people who are going to struggle with it regardless of whether they ask it or not. And so they've got to go for the common ground. And I think the common ground is that they'll actually give you this formula. So saying degrees of freedom is number of participants in group one plus the number of participants in group two. And then we take the sum of that and we take 2 away. Now you don't need the brackets because because I think it's a summative law of addition and subtraction, so therefore it won't make any difference to the answer. And I think what they can do is they'll get you to substitute this in. So, for example, for the first the set of data that we had that wasn't using unrelated, I think it was n was 10 and 14. So you do 10 plus 14 is 24, minus 2 is 22. Okay, something like that. Okay, it's going to be fairly straightforward for you to do. The way I tend to try and remember this is that I ask myself, well, how many groups do we have? And we have 2. So therefore, it's a minus 2. Okay, I have to add up how many people take part in the study and a minus 2, rather than trying to make sense of it in any other way. Okay, so what I have is an example of the critical value table that they could have. We see that we have your levels of significance for 1 tail and 2 tail, and we have your 5% there and your 5% there. So if I did have any actual data for this, I would be, I would want you to, I'd want you to make sure that you chose the correct value according to it being a 2-tailed test, okay? So in this particular case, I'd probably be looking at something like, if it was 22, something like that, okay? Now, like all the tables, it has the statement, it says the calculated value or the observed value. And this is why I do give you both wordings, because it's not sure what they're going to do. So if you are aware that the observed and calculated are the same thing, because it's coming from the data that you have collected, then you should be fine. It said the observed value or calculated value must be equal to or more than the critical value for this table to be significant. And that's it. Okay, so that will give you the value. You write that value down, you write down your critical value, and then you make the comparison as to what you should do from there. Okay. The main difference is the level of measurement. Okay, everything else works the same. We do a comparison between 2 values, we decide whether it's significant or not, and that is your unrelated t-test, and it's unrelated because it's independent groups. Thank you. I hope that was good for you, and I'll continue with this series as soon as I can. You take care.